Hello again. So here's another episode on smart contract security. This time I want to talk about what I call the Revert denial of service vulnerability. And that's compared to the earlier vulnerabilities we've discussed, it's a little more specific to smart contracts and also a bit harder to see. So it should be an interesting one. So here's just the typical scenario on this. Within a transaction, within a function, in some smart contract code, you first do something, and then you transfer ether to someone, or make another external call. But it mainly happens when you transfer ether, and then you do something else, or you might not do something else. But in any case, when you do the transfer of the ether, that might actually be to an external address or to a smart contract. You always have to assume that the address you're dealing with can be a smart contract. So if you're doing an ether transfer or another external call, something will get executed on the other side. So there's an external call if there's a smart contract involved. And anything can happen in there. You don't control this. And if this code here fails or reverts somehow, then because this is executed on transaction, all this here on the left also fails. So the transaction never completes. So the attack scenario here consists in always making this external call fail, and then you basically never be able to execute this transaction here on the left. And here's an example of this. So this is sort of an implementation of a naive implementation of an auction smart contract. It works very simple. So there's a current leader here, which is an address, and there's a highest bid. And basically there's just a payable bid function. And whenever value is transferred to this, there's a check if the bid is higher, or the amount being transferred to the contract is higher than the earlier bid. This succeeds, and there's a refund here, a send operation of the earlier bid to the earlier bidder. So basically the highest bidder or the current leader has his funds locked into the smart contract, and whoever is there when the auction finishes is the winner of the auction. So how does this attack work? Well, this send here to the current leader address can actually be to a smart contract. If currently there's a smart contract, there can be a condition in there that just reverts, that just makes this transaction fail. And then everything here fails, and it means that the current leader remains the leader forever. It means no one can actually place a higher bid. That's why it's called the denial of service attack in this case. So this is something to watch out for, because it's not immediately obvious. And there are a number of things that we can do. And here's just, as always, a list of best practices. If you're dealing with addresses, don't just assume they are external addresses belonging to some wallet. They may actually be smart contracts, and that's very important, because smart contracts can do a lot of things. Next, whenever you do an untrusted external call to someone else's smart contract or wallet, then isolate that as much as possible. And the way to do that with payment is this, what we call the pull over push payments pattern. And that basically means you try to avoid pushing funds out to people. It's best that if your smart contract holds funds that other people might wish or need to receive, you just mark them somehow and then have a withdrawal function, and you actually let them pull for the payment. So in the case of the auction, instead of doing the actual send transfer, you just mark this amount of ether as withdrawable by a certain address, and then this address can actually make the call. And and the complexity of this you deal with on the user level side, on the user interface code, rather than in the smart contract. And that means that this type of attack cannot occur. Anyway, as always, I'll end with a call to remind you to get your smart contracts audited by an expert. And I'll be back soon with more vulnerabilities and smart contract security.